Rewriting limit expressions into definite integral expressions. So what is a definite integral? It is the area under the curve between two specific points. The definite integral can be also written as a limit expression, also known as the Riemann sum, or the integral expression. In this video, we will teach you how to rewrite limit expressions into integral expressions. Video guide. First, we'll go over limit expression, then the integral expression, how to rewrite limit expression, then some practice problems, common errors, and summary and contribution. First, starting off with limit expressions, or the Riemann sum. Limit as n goes to infinity, the summation of I1 to n, f of x of I times delta x is the right Riemann sum. Let's look at each part to make sense of the limit expression. The delta x represents the change of x, which is the base, and is equal to b minus a all over n, where b is the right endpoint and a is the left endpoint, and n is the number of rectangles. X of I is equal to a plus I delta x, which finds all of the right endpoints between a and b. Plug x of I into a function, f of x of I, and this will give you an expression for the height. Now to find the area of the rectangles, multiply the base, which is the delta x, times the summation of heights. Then you want to find the limit as n goes to infinity, because that would mean that you will have an infinite amount of rectangles between a and b. That will make your area under the curve very accurate. Second, integral expression. Now let's look at the integral expression. A and b, just like the limit expression, represents the left and the right endpoints respectively. F of x is the function we want the area under the curve of, and d of x is an infinitely small change of x, which is the base, which is multiplied to the f of x, which is the height. Therefore, integral expression is yet another way to represent definite integral, just like the limit expression. 3. How to rewrite limit expressions. There are 4 easy steps. 1. Find a plus I delta x, which will give you the a and the delta x. Then use the a and the delta x, which is also equal to b minus a over n, to find b. 3. Replace a plus I delta x in f of a plus I delta x with x, so that you have f of x, and find out what f of x is. And 4. Put it all together with the integral and the dx.
Our first practice problem is, write the following summation as a definite integral. So let's go back to those 4 steps we just looked at. So the first ones are, we have to find a plus I times delta x, and then we have to use what we found to find b. This would make more sense in the example, so let's go through it. So first we need to find a plus I times delta x, and here there's the general limit expression format. So when we put this side by side with the given equation, we can see that 5 plus 3i over n, that thing in the parentheses, is equal to a plus I times delta x. So we can see that like it matches. So a equals 5 and delta x equals 3 over n. So now that we know delta x equals 3 over n, we can find what b is. So since delta x is always b minus a over n, and we have a, it means that b minus 5 over n equals 3 over n, and b minus 5 equals 3, so b is 8. And now we have a and b and delta x. So now we want to replace a plus I times delta x with x to find what our function is. So when we do that, we can find that, like, because in the summation it's sine of 5 plus 3 over n, when we replace that with x, we get f of x equals sine of x. So now we have everything. So we can put all this information into a definite integral. So here we have all the information that we found in the last couple steps. So we can write this into a definite integral, which is this. Okay, now for another practice problem. Feel free to pause this video if you need more time. So here's the second question. Rewrite this definite integral as a limit expression. Show your work. Alright, so this is actually even easier. So definite integrals always have a general format that looks like this, where it's a, b, and f of x. So the information is really straightforward and you don't have much to calculate. So when we put that back, when we compare that to our given equation, we can see that a equals 0, b equals 2, and f of x equals x squared. It's even simpler. So what about delta x? Since we know delta x equals b minus a over n, and we know that b is 2 and a is 0, we can conclude that delta x is 2 over n. So when we multiply that by I, we find that I times delta x equals 2i over n. So now we have everything that we need to write it into a Riemann sum. So the answer is this. Alright, so common errors. So sometimes when students rewrite the definite integral into the limit expression, sometimes they'll forget the delta x that is multiplied to f of x of I. This is a pretty crucial error due to silly mistakes, and it can be easily avoided. Also, frequently students mix up a and b up in the integral expression. So just to recap, a is at the bottom of the integral sign and b is at the top. Third, don't forget to add dx to the end of the integral expression. While it might not seem like a big deal, it actually does, because it changes your whole answer. And you can get points taken off on your test if you forget to write this, so don't forget. Also, sometimes students pick the wrong a plus I times delta x when they're given one of these problems like to rewrite. So this might alter the endpoints a and b, or it might prevent them from solving the whole problem. So summary. So by now you should understand what limit and integral expressions are, and that and you should know like this conversion equation, and know how to get from one to the other using the 4 easy steps we talked about and went over through in this lesson. We hope we taught you how to rewrite definite integrals as limit expressions. So we worked on the PowerPoint online, and then we met up to do the recording together. This project helped us understand this crucial calculus concept much more clearly. We hope this video helped you understand it just as well.